Hi students, welcome back. Let me continue with the subject theory of computation. So in this video I want to explain you what are the different applications and what are the different types of automatas. Let's see the applications. So the theory of computation plays an important role in the compiler design. Okay, so it is one of the important role that is going to be play in the compiler design, the theory of computation. In switching theory, if you take the switching theory and design and analysis of the digital circuits, automata theory is applied. So in those subjects also, here what are the applications here means in which fields we are using this theory of computation. So you will get a doubt. We are studying about the symbols, transition diagrams and the transition states and the functions. Where we use all those things. Okay, is it necessary to learn this subject? Right, it's very important to learn this subject because it is playing an important role in the compiler designs and in the switching theory and the design and analysis of digital circuits also. This automata theory is very helpful. In the case of design and analysis of the complex softwares and the hardware systems, in those fields also we are using the theory of computation concepts for complex designing the complex softwares and the hardware systems. And to prove the correctness of the program, automata theory is used. If you are doing something, if you want to verify whether the problem is correct or not, it is executing the correct, whether it is accepting the correct inputs and giving the correct output or not, we have to prove the correctness of our program by using this automata theory. And to design the finite state machines such as Moore and the Mealy machines, to design these machines, we require the finite automata. Okay, the theory of computation is helpful in designing the Moore and Mealy machines. And it is based for the formal languages, and these formal languages are useful for programming languages. So for all the programming language, the base should be this automata theory. So I hope you understand why we are reading this subject, the theory of computations, right? So let me explain you the different types of finite automata before entering into these different types. So in this subject, we are going to learn about this unit. We are going to learn about these different finite automatas. The finite automata is of two types. One is without output and another is with output. Finite automata, it's a 5 tuples consisting of 5 tuples. And these finite automata is of two types. One is without automata, without output, and another is with output. So the finite automata without output, either it can be a deterministic finite automata, non-deterministic finite automata, or non-deterministic finite automata with epsilon moves. So you have to write this epsilon moves. Means we are considering the epsilon also. These three are the different types of finite automata without output. Remember that. These are without output. What is that? DFA, NFA, epsilon, NFA. NFA or NDFA, both are the same. Deterministic finite automata, non-deterministic finite automata, and non-deterministic finite automata with epsilon moves. And coming to finite automata with output. The finite automata with output, the examples for this is Moore machine and Mealy machine. Okay. So in the coming videos, we are going to learn about the DFA, NDFA, epsilon moves with NDFA, Moore machine and Mealy machines with an examples. Right? Thank you.